Today's video is covering section 3.3, Graphing Systems of Inequalities. Before we get into that, I want to review a couple ideas that we're going to use with our systems. So we're going to first start by graphing the inequality on a coordinate plane. We just recently did this. So we start with our y-intercept up at 5. We have a slope of 3/4, so we're going to go up 3, right 4. We're going to build it in the other direction as well, so down 3, left 4, down 3, left 4, keeping that slope of a positive 3/4. Now we want y to be less than that line. So we know that it's going to be a dashed line. And if we want it to be less than, we are going to shade below the line. If you're still not sure which way to shade, remember you're going to use a test point. If I plug in my point of 0, 0, I'd have 0 is less than or equal to, just less than. 3/4 times 0 is 0 plus 5. 0 is less than 5. That is true, so I'm going to shade in that direction. So that's graphing a simple inequality. If I want to graph an inequality on a number line, this is a compound inequality because I've got two of our inequalities. I've got a -4. We've got to solve this one over here. We divide by a -2. And hopefully you remember with inequalities, when you divide by a negative, you've got to flip the sign, so our less than becomes a greater than. And this is an AND problem, so we've got two numbers, a -5 and a -4. We want it to be greater than or equal to a -4. We want it to be greater than -5, open circle to the right. And because we have an AND problem, we are looking for the overlap. What do those two share? So this would be my solution on top. And last is graphing a system of equations. So if we want to graph the system of equations, we find our solution by finding the intersection. And we start with our first line, our y-intercept of a -1. We have a slope of a -3/2, so I'm going to go down 3, right 2. Down 3, right 2. We're also going to go up 3, left 2, up 3, left 2. There is our first line. Our second line, we have to solve for y before we can graph. So we move that 4x over. So we've got a -2y is equal to a -4x plus 12. Divide by a -2, y is equal to 2x minus 6. So we have that y-intercept down there at a -6. We have a positive 2 over 1 as our slope. And hopefully you remember that since I don't have a dot on top of a dot, I would have to go into my calculator to find that intersection point. And hopefully you remember. If not, we need to come back and review that later. So our intersection point is 1.43, comma -3.14. So we're going to take all these ideas, the idea of an inequality, of our compound inequality on the number line, and of our system, we're going to put all three of those ideas together to graphing systems of linear inequalities. So let's start. We are going to graph our lines. So we've got a y-intercept down at -4. A slope of 1/3, we're going to go up 1, right 3, up 1, right 3. Continue your pattern. Continue it in the other direction as well, covering our entire graph. And it's a greater than sign, so we are going to have a dashed line for that graph. And it's going to be greater than, so we are going to shade above our line. Now we need to go to our second equation, or inequality. We've got a y-intercept of a +3, and we have a slope of a -2. So we're going to go down 2, right 1, 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 down 2, right 1. You can also go up to left 1, continuing your line for the entire graph. And in this time, it is important that you are going to cover the entire graph. Luckily, I was correct in doing a solid line because we have a less than or equal to sign. Now, since I went less than or equal to, I'm going to be graphing to the left. And again, if you don't remember which way to graph, you've got to use that test point. Now what I'm going to do is I've I've done my inequality, I've done my system. Now I have to take in that idea of the overlap. My solution set is, what do they both share? I need it to be above my first line and to the left of the second line. So my solution set is the area that they both are covering. And if I look, this is the area that is covered by both of the graphs. So this would be the area that would be considered the solution set, because it covers the blue line and it covers the red line. So I would shade my solution set everything over there. So if I could erase that and erase that, that would be my answer. That would be my solution. If we want to name any 3 points that satisfy the system of inequalities, it would be anything inside of here. So we're going to check, is negative 5, 3 a solution? So if I go negative 5 up 3, yes, that is inside, so that is going to be a solution to our system. Is 1, 1 a solution? 1, 1 is. Hopefully you guys know that it is going to be a solution because it's on a solid line. And we know that a solid line means that the line is included. And then we have 3, negative 3. So 3, right 3, down 3. That is going to be a no. So if you hopefully remember when we talked about is a point a solution to a system, it has to be true for both equations. And if we look at our blue line is dotted. So that line does not include that point. It is included in the red one, but not in the blue one. And if it's not part of both of them, it's not part of your solution set. So remember, it's got to be part of both. That's the main idea there. Alright, so let's do some more of these. Turn over to the back page. Graph the following systems of inequalities on your graphs. So y is less than or equal to 3x. Sometimes the simpler the equation, the more it throws you off. So just remember that your y-intercept there is 0. If there is no number, it's at 0. A slope of 3, up 3, right 1. Continue your path in both directions, making sure that you cover the entire thing. And then we look, less than or equal to means that we're going to have a solid line. If I want it to be less than that line, I'm looking at everything below to the right in this case. And then I look at my second line. It's greater than a negative x plus 5, so we start off at a positive 5, a negative 1 slope, so we're going down 1, right 1. We're going to continue that. Keep going. Keep going. Other direction. And we look at this and it's greater than, so we're going to have a dashed line. It's kind of harder when you have so many dots representing your slope. Just make sure that it's clear which one is dotted and which one is solid. And we want this one to be greater than, so this is where we would be shading above the line here. And again, our solution set is where both graphs are being shaded. Here it's only red, here there's nothing, down here it's only blue. Our solution set is going to be all of our graph in here, where we have our blue and our red graph. Okay. Next one, number 3. We've got y is greater than 5/3 x minus 4. So we start down at a negative 4. 5/3 slope, we're going up 5, right 3. Up 5, right 3. Then we've got to make sure that we go in both directions. So we're going down 5, left 3. Greater than symbol means we've got a dashed line. And because it's greater than, we are going to shade there. Our second one, a couple different options. You could do intercepts, but then you're going to have a nasty fraction there. So what I would do would just be put in slope-intercept form. So 4y is greater than a negative 5x minus 8. Divide by 4. And we've got y is greater than a negative 4/5 x minus 2. So we start with our y-intercept down at a negative 2. A slope of a negative 5/4, so we go down 5, right 4, we run out of room, so we go up 5, left 4, up 5, and left 4. And we have a greater than symbol, so we're going to have a dashed line going through. So in this case, both of our lines ended up being dashed. If I want it to be greater than, we are going to be shading over here. And once again, we are looking for the overlap. So let's make this a little more obvious. This is the area in which both of our lines are shaded. So this would be the area of our solution set. So make sure that you've got it clear each time. Where are your two graphs overlapping? Moving on. We only got 2 left. We look at number 4. With number 4, what I want you to do first is start off by putting both equations in graphing form. Solve both of them for y, or you can solve using your x-intercepts. It doesn't matter, either one. See if you can get those two correct. Press pause for right now, press play when you're done. I want you to check your equations before you move on to your graphs. Alright, let's see how you did. For the first one, if you solved in slope-intercept form, you would have gotten y is less than or equal to 3/4 x plus 3. If you did the intercept form, you should have gotten your x-intercept to be -4, 0, your y-intercept to be 0, 3. For your second equation, if you solved for y, you would have gotten y is greater than or equal to 3/4 x minus 6. If you had your x-intercepts, it would have been 8, 0, and 0, -6 for your intercepts. I would highly, highly, highly recommend you use graphing form. The only reason is it may be easier just to plot the 2 points for your intercepts, but when you have the intercepts, you really don't have an idea of which way to shade. So you have to use a test point every single time and make sure that you're double checking all of your test points, that you're shading the right direction. If you have the equation, it's a lot easier looking at the equation which way you have to shade. Alright, now that you have your equations, press pause, graph your lines, and graph your solution set, and see how you do. Alright, hopefully you saw that your two lines were parallel, same slopes, different y-intercepts. Some of you may be thinking to yourself, do I have to graph all the shading, or can I just graph the solution set? You can just graph the solution set if you are that comfortable. If you look at the blue line, we want it to be less than or equal to, so we had a solid line. We would be graphing below that line. Our second one, we are greater than, so we have a dashed line, and we are going above. So the area in which they are sharing, which they both are being shaded, if it's below blue and above red, it would be everything in between. So if you want, at this point, you can only graph or shade in the solution set. You don't have to show me all 3 pieces. You are more than welcome to do all 3 pieces if that's what makes you feel more comfortable. Okay, number 5, we have 3 pieces. So we start with our first line, up at 7, a slope of a -7/8. So we're going down 7 and right 8. We don't have any other room for any more lines or any more points. It's going to be a dashed line because it's less than. And in this case, it's less than, so we are going to shade everything below your line. Our second line, we've got y is greater than or equal to 1. That's a solid horizontal line at 1. And because we want it to be greater than or equal to, we would be graphing everything above that line. And last, we have x is greater than 2. That's a vertical line at 2, and that is going to be a dashed line. And if it's greater than, we are going to be graphing everything to the right. So in all of this mess, we are looking for everything below the blue line, above the red line, and to the right of the green line, which means our solution set is this one small triangle inside those 3 pieces. And again, if you feel comfortable enough, you can only graph the solution set. You don't have to graph all of the pieces. Graph all the pieces until you can see where all 3 of them overlap. And we are done. That was our last problem for today.